Hello viewers, I am Dr. Mala Das Sharma, retired professor of St. Pius X Degree and PG College for Women, Hyderabad. Welcome to my channel Chemphilic. So let's start the 23rd episode of Teaching Chemistry through Riddle. Do watch the video till the end and answer the viewer's question which will appear on the screen at the end of the discussion. From riddle number 20, I am keeping a question related to the riddle for the viewers. I am happy to receive the responses from the viewers. Time to time, I will announce the names of the viewers who have sent the correct answer. Dates of announcement will not be revealed in advance. So, watch the video regularly and answer the question of all the episodes. So, let's start riddle number 23. X is an effect associated with the phenomenon Y. Y is involved in a technique of identification of organic compounds. The phenomenon Y associated in this identification technique is responsible for the shifting of the absorption position of the protons present in different locations of the compound. The phenomenon Y is influenced by many factors and X is one among them. The effect X makes changes in Y and thereby it causes unexpected shifting of absorption position of proton in pi-bonded organic compounds. So, this is our riddle number 23. Now, let's see the question. The first question or primary question is, what is the technique mentioned in the riddle? Name the phenomenon Y involved in the technique. Name the effect X. So there are three parts in this primary question. So let's see the answer. Answer of the first part is nuclear magnetic resonance spectroscopy. The answer of the second part is chemical shift. And the answer of the third part is anisotropic effect. Now let's see the other questions related to this riddle. Second question, mention the factors affecting Y. Third question, how the effect X is generated. Fourth question, give an example of an organic compound where the effect X can produce unexpected value of Y. Now, this riddle is framed to explain the factors affecting chemical shift. Now, chemical shift, shielding and de-shielding, all this I have discussed in my previous video. So, any factor responsible for shielding and de-shielding of a proton will affect its chemical shift. And these factors are, number 1, electronegativity, number 2, anisotropic effect, number 3, hydrogen bonding. Now let's discuss electronegativity and inductive effect. Now see, this molecule is methyl fluoride, where carbon atom is attached to 3 hydrogen atom and 1 fluorine atom. And fluorine atom is electronegative and it exerts strong minus I effect. And by this strong minus I effect, it attracts the electron density towards itself. And this inductive effect transmitted through the chain, and therefore this electron density around this hydrogen atom is less because it is attracted towards this carbon atom. As this electron density around this hydrogen atom is less, so this hydrogen atom or any one of this hydrogen atom, they are in the de-shielded position. De-shielded position means they will absorb at lower magnetic field. That means delta value will be high. Now, from methyl fluoride, when you switch over to methyl chloride, chlorine is less electronegative than fluorine. So, minus I effect also will be less than fluorine. So, this hydrogen atom is in the de-shielded region, but here the electron density around this hydrogen is comparatively more than this hydrogen in the methyl fluoride. And when you are coming to methyl bromide, bromine is still less electronegative. So this hydrogen atom of this methyl bromide, it is comparatively less de-shielded position than methyl chloride hydrogen atom or methyl fluoride proton. Similarly, the last one, iodide, whose electronegativity is the least compared to all this halogen atom. So, this hydrogen atom is in the least de-shielded position. That means it will absorb at comparatively higher field. Okay? And therefore, its delta value will be less compared to all these things. Now, the degree of shielding depends on the electron density around a proton. The higher the electron density around a proton, higher the shielding and higher is the field. Higher is the field means lower delta value at which the proton absorbs. Now, nearby electronegative atom withdraws electron density due to minus I effect from the neighborhood of the proton. So, NMR signal of such de-shielded proton, that is proton surrounded by less electron density, as I told here, will appear downfield, that is higher delta value. Now, this is the graphical representation of this chemical shift delta versus the electronegativity of this halogen atom. So, iodine is least electronegative, then bromine. Bromine is more electronegative than iodine, then chlorine and finally fluorine. So, as the electronegativity increases from iodine to fluorine, that means from methyl iodide to methyl fluoride, this delta value or chemical shift increases. That means the chemical shift is shifted towards the downfield from methyl iodide to methyl fluoride. So, thus the greater electronegativity of the atom, greater is the de-shielding of the proton. The chemical shifts of protons of methyl halides, you see methyl fluoride, it is 4.26 maximum delta value, then methyl chloride 3.05, then methyl bromide 2.68, then methyl iodide 2.16. That means the delta value is minimum here in methyl iodide. That means its absorption is comparatively upfield compared to all, are in accordance with the electronegativity of the halogens attached to the methyl group. Now coming to anisotropic effect. See, this is acetylene molecule. Now in acetylene molecule, carbon atom is sp hybridized. sp hybridized means it has more S character. And more S character means this bonded electron pair, that means carbon-hydrogen bonded electron pair, will be more strongly attracted by carbon nucleus. That means the acetylenic carbon atom is more electronegative. And as it is more electronegative, so electron density around this proton will be less. So, electron density around this proton less means it is expected that it is in the de-shielded position. Its delta value will be high, okay, in the downfield. So, it is expected that this proton of acetylene molecule is in the de-shielded position, which we are explaining from the electronegativity of the carbon. Now, coming to alkene. This is ethylene molecule. Now in ethylene molecule, carbon atom is sp2 hybridized, where S character is less compared to the sp hybridized carbon atom. So the carbon atom of ethylene molecule is less electronegative. Therefore, electron density around this carbon hydrogen bond will be, or around this hydrogen or around this proton will be comparatively more. So what we expect that this hydrogen atom of the proton is comparatively more less deshielded position than that of the hydrogen atom of the acetylene. Okay. Now carbon atoms of acetylene is more electronegative than that in ethylene. But acetylenic protons are more shielded than ethylenic protons. For acetylenic proton, delta is 2.35. We are expecting it was deshielded, but actually it is shielded compared to ethylenic proton because the delta value is 2.35. For ethylenic proton, delta is 4.60. Now, that means the electronegativity can correlate the chemical shift in some compound, what we have observed in that methyl halide. However, in some cases, for example, in acetylenic, olefinic, aldehydic and aromatic protons, chemical shifts cannot be explained on the basis of electronegativity. Then, now we'll see. This anomaly, that means this acetylenic proton is in the more shielded region than ethylenic proton, and this is true for this aldehydic proton and then this aromatic proton. All these things we will discuss. Now this anomaly can be explained by the induced magnetic field generated by the circulation of pi bonded electron in presence of the applied magnetic field. Okay, and so such anomalies are explained on the basis of anisotropic. This effect is called anisotropic effect. Anisotropic effect produced by the circulation of pi electrons under the influence of the applied magnetic field. And this anisotropic effect depends on the orientation of the molecule with respect to the applied magnetic field. And this anisotropic effect, which is generated by the circulation of pi bonded electrons or pi electrons in presence of applied magnetic field, this effect is in addition of this induced magnetic field generated by the circulation of the sigma electron or sigma bonded electrons. So, these effects depends on the orientation of the molecule with respect to the applied field. Anisotropic effects are in addition to the induced magnetic field generated by the circulation of sigma electrons. Now, generally, this induced magnetic field generated by the circulation of the pi electron is stronger than generated by the sigma electrons. Now, once again, we will coming to this acetylene molecule. Okay. Now, this induced magnetic field generated in acetylene molecule by the circulation of this pi bonded electron in presence of the applied magnetic field, it reinforces this applied magnetic field in this region, which is at the direction of the applied magnetic field. That means in this region it reinforces the applied magnetic field, but outside this region here it opposes the applied magnetic field. So this region are deshielded position, and this region where the hydrogen or proton of the acetylene molecule is present, here this is the shielded position. That means here this induced magnetic field opposes the applied magnetic field. So this proton is experiencing less magnetic field, so it needs more external magnetic field for its transition. So its chemical shift will be upfield comparatively, and delta value will be less. So acetylenic proton is additionally shielded and its signal moves higher field than expected from the electronegativity of the acetylenic carbon. Now coming to ethylene molecule or alkyne. See, if the ethylene molecule or this alkyne is oriented perpendicular to the direction of the applied magnetic field, then that induced magnetic field generated by the circulation of this pi bonded electron will reinforce this applied magnetic field in this region, in this position, that means which is at the direction of this applied magnetic field, and it opposes the applied magnetic field in this region, here and here. But at this orientation, the protons are placed in the de-shielded region where this induced magnetic field is reinforcing the applied magnetic field. So as these protons are in de-shielded region, that means it will absorb at lower field, that means higher delta value. So when an alkene molecule is oriented perpendicular to the applied magnetic field, the induced magnetic field generated by circulation of pi electrons has the same direction at the olefinic proton as the applied magnetic field. Thus, induced magnetic field reinforces the applied field, resulting in de-shielding of olefinic proton. Consequently, the protons absorbed at lower field than expected from the electronegativity of the olefinic carbon. Now coming to the anisotropic effect in aldehydic proton. Now here also this molecule is oriented perpendicular direction with respect to the direction of the applied magnetic field. So this induced magnetic field generated by the circulation of this pi bonded electron, it reinforces the applied magnetic field in this direction, that means direction of the external magnetic field. And you see the aldehydic proton is in this region. This region is de-shielded because here this induced field is reinforcing the applied magnetic field. So this proton is in the de-shielded region. Moreover, here oxygen atom is more electronegative. It attracts the electron density towards itself, and thereby also this region will become more and more de-shielded. Therefore, this aldehydic proton absorbs at lower magnetic field and its delta value is high. So, when an aldehydic group is oriented perpendicular to the applied magnetic field, the circulation of pi electrons generates an induced magnetic field which reinforces the applied magnetic field at the aldehydic proton, resulting in its de-shielding. Thus, aldehydic proton absorbs at much lower field. Delta value is 9.5 due to combined effect in the high electronegativity of oxygen and anisotropic effect produced by the pi electrons of the carbonyl group. Now coming to the anisotropic effect of aromatic compound, so benzene ring. We know this aromatic compound or say benzene ring, that pi electron cloud is present above and below the ring. Okay. Now, if you apply the external magnetic field perpendicular to the plane of the molecule, then the induced magnetic field generated by the circulation of pi electron, that induced magnetic field also will be in the direction of the applied magnetic field. That means this induced magnetic field will be perpendicular to the plane of the molecule, and in this region that is at the direction of the applied magnetic field, it is reinforcing the applied magnetic field. That means these regions are your de-shielded region. That means this induced magnetic field generated by the circulation of the pi electron reinforces the applied magnetic field outside the ring. See this is outside the ring, and it opposes the applied magnetic field inside the ring. Okay, and therefore this hydrogen proton of this benzene ring, they are in highly de-shielded position, and this is called ring current effect, and this is the strong evidence for aromaticity. So aromatic ring contains delocalized pi electron clouds above and below the plane of the ring. When a magnetic field applied perpendicular to the plane of the ring, circulation of pi electrons produces a ring current which induces a magnetic field perpendicular to the plane of the ring. So these protons attached to this benzene ring, they are outside the ring, they are in the de-shielded position. But if the protons present above and below this ring, they will be in the shielded position. So see, induced field is in the same direction as the applied field outside the ring, as I told. So here it is reinforcing the applied field, but inside the ring it opposes the applied field. Now, aromatic protons in the benzene are highly de-shielded and hence appear at lower field. This is called ring current effect, and it is used as very strong evidence for aromaticity. And the protons held above and below the plane of the aromatic ring, just plane of the aromatic ring, are shielded due to the ring current effect. Now coming to the effect of hydrogen bonding. We know that the condition of hydrogen bonding is the hydrogen atom must be attached to a small electronegative atom. Say here it is attached to oxygen. Then that hydrogen atom which acquires partial positive charge, it gets attached with another partially electronegative atom through a weak bond, that is hydrogen bond. Okay. So therefore electron density around this proton will be less. So this hydrogen bonded protons will be in the de-shielded region. De-shielded region means delta value will be high. So hydrogen bonded protons absorbed at lower field than the non-hydrogen bonded protons due to high electronegativity of the atom to which the proton is hydrogen bonded. Thus hydrogen bonded protons are highly de-shielded and absorbed at lower field. Now coming to the answers of the remaining question. Second question was, mention the factors affecting Y. We have discussed already. Electronegativity, anisotropic effect, hydrogen bonding. Third question was, how the effect X is generated. So generally the anisotropic effect of the induced magnetic field responsible for this effect is generated by the circulation of pi electrons, and it is stronger than generated by the sigma electrons. Now fourth question, give one example of an organic compound where effect X can produce unexpected value of Y. Say acetylenic proton, it is additionally shielded by the induced field generated by circulation of pi electrons. The signal moves higher field than expected from the electronegativity of the acetylenic carbon. So this is our riddle number 23rd. Now let's see the question for the viewers. Now today's question is, in a given molecule, which protons have higher delta value? A protons or B protons? That means in the molecule, two types of protons will be there, A protons and B protons, which have higher delta value. The molecule is this one. So send the answer as early as possible and mail your answer to this mail ID malachemphilic@gmail.com. You have to write your name, affiliation, but it is not mandatory. Then you have to write the place from where you are sending the answer, and then you have to write answer of the viewer's question of riddle number 23, then give your answer and send me at your earliest. So join me in this program and thank you.